You've connected to Cisco Unplugged.
Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Klamert, your host, and this week on episode 42, we're going to be discussing mDNS best practices. So I would like to welcome back to the show Mr. Al Dumdei. How are you doing, Al?
Good. Thanks, Dan. How are you doing?
I'm doing great. Good to see you. Thanks for coming back.
My pleasure.
So before we get started, I just wanted to remind our viewers a couple of things here. If you do have questions, we use Slido and we are taking those questions live here today, as usual. You can see that under the video on YouTube where you're tuned in and join the Slido there. It is also up on the screen here as well. You can join via that way. And then, as usual, we do record these episodes and they are posted to our YouTube channel, youtube.com/@getunplugged. And I would encourage you to like and subscribe out there to be sure you are notified when we do post new content. And we do have a follow-up to this as well, this episode. So you'll be notified when we do go live with the kind of the part 2 of this or second part of the episode as well. So, all right, with that, let's get unplugged. Al, let's talk mDNS. So first off, what does the M in mDNS stand for?
Multicast, right? See, good
Right.
question. Yeah. And I like this topic because it's one of those things that I think it's kind of the thing that people sort of love to forget, right? Because multicast in general is kind of a specialty, and then you add mDNS on top of that, and it kind of tends to get lost in a lot of the deployments. On the other hand, mDNS is one of those things that can jump up and bite you if you're not paying attention to it, right?
True.
And so I think it's important that even if you have a small deployment, that we understand mDNS, right? mDNS was really meant for your home application.
Exactly. It works great in the home, I was going to say.
Right.
People are used to it working just seamlessly, and then they go to the enterprise and they expect the same.
Right. And then we get in an enterprise environment or, like an ISD or, a large university. And then all of a sudden we're overrun by all these mDNS messages. And it really makes it, not only does it make mDNS useless in that case, it also pollutes my spectrum. It, causes more CPU drain on my devices. And it's one of those things that, we really need to know how to manage what it is and how to manage it in the network. It's an important function in our wireless network. So
yeah,
again,
absolutely.
It's kind of that thing everybody loves to forget about, but
yeah, it's great at home when I look and I see, okay, I've got my living room TV or my printer or whatever. It's just a couple things. But when I'm in the campus network and I pull up that list and I see hundreds of things,
right.
It's like, wait a minute here. Where's my device?
And yours probably isn't even getting broadcast, right? Because it's
maybe not.
There's not enough bandwidth for that, or
Yep.
It's like, so yeah, so it can be very menacing if you're not paying attention to it. So the goal here is kind of educate everybody on. Well, we're going to talk a little bit about multicast to start with in general, right? Because I think again, to your point, it is multicast DNS. So multicast DNS, as we know, is a way to find things, right? And so to resolve things on the internet. Multicast DNS allows us to resolve devices on our network, right? So maybe it's an Apple TV, maybe it's a printer, but we can use multicast DNS to resolve these locations. Multicast DNS is not something we use to serve video or something like that. Multicast we might, right? But mDNS is a little bit different. We'll talk about how mDNS is different than just plain old multicast. But I think to start with, let's talk a little bit about multicast in general.
Yeah, that sounds
good. Multicast can be, like video applications. There can be custom applications. I've seen this a lot in paging applications. We use multicast in a lot of like hospitals for paging devices. I've seen it in airports. And then Bonjour is kind of that Apple name brand that we know mDNS as. So oftentimes we call it Bonjour. But when we're referring to Bonjour, we're also referring to mDNS, all right? And so let's look at multicast in general, right? And we're gonna jump into that Bonjour multicast case last here in just a little bit. So in this particular case, I have a network, and that network is separated by some layer 3 connections, and that could be multiple hops of layer 3, right? So if you see these layer 3 clouds over here on either side. those could be multiple layer 3 hops. And so just to simplify this, I put a single layer 3 hop between the AP and the controller. One of the things that we do, so the APs, as I think everybody knows, can either run in something called Flexconnect mode or local mode. And the Meraki APs traditionally will run in kind of that same Flexconnect mode, that locally switched. And just so we don't confuse everybody, we have locally switched, which means we're connecting to that local switch. And then we have centrally switched. Those APs run in local mode, right? So we'll try to refer to as centrally switched or locally switched just to kind
So
of
it's
keep
really a
that.
matter of, am I tunneling all that traffic back through a central controller or something like that, or am I switching it locally at the switch my AP is connected to?
Exactly.
Yeah.
Exactly. And so one of the big advantages of that centrally switched model is we run all of our multicast through a multicast tunnel from the AP. So traditionally, if I had something like this where I had a multicast source on the network, I would have to run layer 3 multicast, so PIM, right, is the kind of the traditional way of running multicast, maybe sparse mode, set up, all of my rendezvous points, and maybe I'm doing mDNS and all that sort of. So there's lots of things that are part of setting up multicast. We can simplify a lot of that with this centrally switched deployment, because we just need one VLAN in this whole deployment to have multicast on it, except of course the VLAN that the multicast source is on. And so the way this is going to work, the way multicast works in a centrally switched environment is the multicast receiver, of course, would send its request to join its IGMP message up to the layer 3 interface. The layer 3 interface would then store that, right? So the layer 3 interface now knows, hey, I've got this source on this particular multicast address that if somebody wants to join, I can send you a join request, right? So, or I can honor that join request. And so now I have a client that's wireless, right? And he's attached to that AP and he wants to join that source. So he sends out a multicast request, right? So he sends out an IGMP join request. That join request gets put into the multicast tunnel and gets tunneled up to the wireless LAN controller. So you notice the only VLAN on here that's handling multicast traffic from the AP, doesn't matter which VLAN it's going to end up on ultimately, is only that AP VLAN. Now, in this particular case, let's call it VLAN 10. So the source is on VLAN 10, so I want to join VLAN 10. What's going to happen is the wireless LAN controller is actually going to proxy that request out to the layer 3 interface. And that layer 3 interface then is going to honor that request and allow that multicast traffic then to flow back through the controller and down to that through that multicast tunnel back to the client. So the beauty of this is we simplify what has to be deployed on the wired side, right? We don't have to put PIM on every interface and all that sort of stuff, right? We don't have to. We only have to worry about one VLAN. And then, of course, if there's anything on the wired side that we need to allow. And I show this multicast traffic going to the same side, the same layer 3 network that the source is on. It really wouldn't matter. I could have had that layer. I could have had done the same example with the client on the right-hand side, for example. Okay. All right. So the other mode we talked about is locally switched or Flexconnect. In locally switched, we move all of those requirements from a multicast standpoint to the local switching infrastructure. So now you can see these little layer 3 interfaces here do have to have multicast so layer 3 multicast is a part of that if we're going to have a layer 3 infrastructure. So we'll be running PIM on all of those VLANs. But the kind of the cool thing about the way Flexconnect works is I no longer need the controller to manage all that, right? So if we go back one slide here, we look at this, right? The controller is managing all of that multicast traffic. In this particular case, I don't need that, right? So I just have the AP VLAN that's just doing management traffic back to the controller, but otherwise all my data is managed locally. We're going to talk about, in particular, how Flexconnect is different with mDNS relative to what Flexconnect local switching is different than central switching with mDNS. So bear this in mind. So these are the two topologies we're going to look at. All right. This an example of we're just doing everything locally here on this switch, right? So all that traffic gets brought here locally. Okay. One of the other things to be aware of with multicast traffic is we also have the ability to convert this from multicast over the air, or really multicast over the air is broadcast, right? So we have the ability to convert this from broadcast effectively into unicast, multiple unicast streams. And we can do that both on the Catalyst technology and on the Meraki technology. Both have the ability to convert that. This is typically a big advantage, again, from a multicast standpoint, if we're doing a lot of multicast traffic where we're sending video streams, because it's a reliable communication now. So if I'm just broadcasting it out, I'm just hoping everybody gets my packet. And if they don't, sorry, you didn't get it. But with true multicast, unicast, what we can do is we can convert those to unicast streams over the air and get acknowledgments back from the client and resend it. Now, the reason why I bring this up is, if you remember on that first slide, is we had something called multicast unicast versus multicast. And so and we're going to look at this from a configuration standpoint. In what I described to you was multicast, that very first with the centrally switched, because we're sending that multicast traffic back on that multicast CapWAP channel effectively. Multicast unicast basically says, okay, once that request gets to the controller, I'm going to turn that into a unicast message and send it out to each client unicast. So even if I don't have any multicast infrastructure, maybe I've got a small office, I didn't set up multicast, I can do multicast unicast. The problem is multicast unicast does not scale, right? So you start replicating all these packets, you're using up bandwidth, you're using up CPU, you're using up switch CPU. It's not a good way to scale from a deployment standpoint. So we typically will recommend, and as we're looking at mDNS, one of the first things we're going to do is we're going to set up that multicast environment. So we have those APs in a multicast stream. Okay.
Yeah. So Al, just to double click on that here real
Yep.
quick. So multicast, unicast, simpler to set up because I don't need to configure my wired infrastructure for multicast, but has a scale limit ultimately. Whereas, and I've had customers ask me this in the past too. It's like, hey, I configured the controller for multicast. How come it's not working? And then your next question is, well, did you configure multicast on the wired network? And then that's where it breaks down. So
exactly,
you need to, I guess, I want to reiterate that you need to configure in multicast mode, which is obviously going to help a lot of our larger customers scale. There needs to be some work done there, right?
Right. And in particular on the AP VLAN, right? So that's the one that we need to make sure we get that multicast infrastructure. If you're running PIM or whatever to get across those, if it's all layer 2, we don't care. But most of our, especially from an AP management standpoint, most of those are layer 3 interfaces on most of our deployments. So we just need to make sure we put that PIM infrastructure on that layer 3. VLAN. Yeah, on the VLAN, wherever that layer 3 interfaces for that VLANs.
True.
Okay. No, good point.
Thanks.
All right. So now let's jump into mDNS, right? So this is a little bit different. And again, you probably hear this called Bonjour sometimes. Sometimes you'll hear it called mDNS. So a couple things that are unique about mDNS. UDP port 5353, multicast address, which is a link local address of 224.0.0.251. Link local by definition means the time to live is 1. All right. So let's say I didn't want to use any sort of mDNS gateway. I just want to let my mDNS messages propagate natively. How would that work? It wouldn't, right? Why is that? Because I can't route something with a time to live of 1. So all the PIM in the world doesn't fix mDNS. So along comes the gateway, the mDNS gateway, right? And that's how we're going to allow the various devices across these layer 3 boundaries to learn about mDNS advertisements, right? And maybe just a brief discussion on how mDNS works. So we talked a little bit we went through that messaging on IGMP and how devices would join from a multicast standpoint. mDNS traffic is not the same, right? We're not sending IGMP messages for mDNS traffic, right? What we're sending mDNS messages. We're sending them to this multicast address, this 251 multicast address. We're sending it on a particular port. to the mDNS MAC address, right? So it's a very specific set of messages where the first thing's going to happen is a device is going to send out a probe and say, hey, is anybody else offering this service? If not, then the device is going to say, okay, here's my service. That is going to be taken in, and I'm going to emphasize the word in because we're going to come back to the in part here in a second. That's going to be taken in by the gateway, right? So it's going to be learned by the gateway, provided we're not filtering it out. It's going to be learned by the gateway. The client that wants to join is going to send a message out, and he's going to say, hey, does anybody, I'd like to know about this service. And then that service will get advertised out to the client. The client can then go, okay, tell me more about that service. And then the particulars on that service would be sent back to the client. That's out from the gateway to the client. All right. So we have the subscriber or the client side, and then we have the advertisement side. The advertisement side is building the database in the gateway. The client side is gleaning from that information learned in that gateway. Okay. All right. So let's look at this sort of logically and think through how this is going to work. All right. So first thing is I have D1 and D2, and they're on a switch together. By the way, that little BA in the switch itself, we're going to talk about that at the very end. That's a gateway we can put on the switch itself and stop this whole flood and learn process from an mDNS standpoint altogether if we want to, right? So it's a fairly new and innovative way to manage mDNS across your network. But today we're going to focus on the wireless, how we do this with the wireless networks, right? So if I look at D1,
there's two questions here, and
Yeah,
I'm sorry to interrupt,
sure.
but I know
Yeah.
you're going to cover the mDNS-AP I think on this slide, or coming shortly.
Yep.
One of the questions is around, as I look at a configuration guide talking about the mDNS-AP setup, I can't find anywhere how to configure, let's see, anywhere to set up the AP mode as an
Yep.
mDNS-AP. Any guidance would be appreciated. Was this special firmware? And the other question is related to firmware as well, version of code to support mDNS on 9800. I know you have a code version up there in the top right corner, but those are the two questions.
Yeah. So, okay, let's drill down into that. That's a great question. All right. So number one, mDNS-AP was introduced from the very beginning. Really 17.3 was where all of the functionality was kind of kicked in from the controller side, but it's always resided on the AP. Sure. Number two, how do you configure it? I'm going to show you at the very end that one of the very last things you're going to see is the configuration for the mDNS-AP. It's a one, yeah, exactly. It's a one-line CLI only command. All right, so that's important to understand. You can only configure that from CLI. Third thing with mDNS-AP is it only works with local mode or monitor mode APs. All right, so back to that centrally switched model, it only works with that centrally switched AP. You're not going to be able to do that with a Flexconnect AP. But we're going to talk about how we can do Flexconnect, right? So that's kind of a different model altogether. All right.
Yeah. Thanks. So, didn't want to interrupt your flow, but I thought
no, all good. Please. I mean, the questions are great. So, yeah. So let's look at D1. D1 is attached to VLAN 30. VLAN 30 is attached to the WireSync controller. Mm-hmm. I'm turning on snooping on the interface on the controllers. Remember, I've enabled a multicast traffic on my controller from the very get-go. So I am seeing that mDNS traffic from D1. Or D1 could see information from my gateway. Even though he's not a wireless client, he's strictly a wired client. All right. Mm-hmm. D2's out of luck, right? Because he's on a different VLAN. That VLAN's not stretched to the controller at this point. This is where potentially we could look at that agent on the switch, but at this point, we won't. That's the next episode, if you will, to get into that discussion. All right, then we have the traditional kind of CapWAP AP that is set up to do that centrally switched model. D3, D4 can talk to D1, no problem. D4 can advertise. D3 can receive from a client standpoint or advertise. They all have the ability to interact with each other from an mDNS standpoint. So all good there so far, no issues, right? And then we have the D5 over here. That's a layer 3 hop away, kind of like D2 was, but it's actually layer 3 connected in. So that means that AP that's over there on VLAN 50 can talk to the controller via a layer 3 interface. Mm-hmm. That CapWAP channel is connected up to the controller. we can put that into exactly what we just discussed a minute ago, an mDNS-AP so maybe not everybody knows what an mDNS-AP is. An mDNS-AP, it allows us to basically sniff the wired side and then report back to the controller what Bonjour services or what MDNS services are available on the wired side. So D5 is learned by the AP on VLAN 50. And so really the AP VLAN could potentially be VLAN 51 even, right? Because that's a trunked interface between the AP and the switch. And so we can trunk up to 10 different interfaces to that AP and snoop 10 different interfaces, so 10 different VLANs onto that AP. And then
the mDNS-AP is basically like a remote pair of eyes and ears for a controller that's somewhere off that, is not necessarily reachable maybe.
Yeah, exactly. That's a great way to put it. But the one thing I will add to that is it's also an AP, right? So I'm not taking this AP and like putting in some dedicated mode. I'm just adding this functionality to it. Okay.
Very cool. And
this is going to be important when we talk about proximity, right? So we can actually tell if different wired devices are in proximity to wireless devices, which is kind of cool. We're going to get to that here in just a second. I'm going to have to hit the fast forward button here. So, all right. So yes, we can do a Bonjour or MDNS in Meraki. Yes, we can do it in Catalyst. With Catalyst, with Meraki, we have the ability to filter based on protocols. With Catalyst, we have the ability to filter on protocols, but we also have the ability to filter on location. And this is very important, right? So as I look at these, I'll just kind of walk through this list real quick. We'll take just a minute to talk about these different things. AP location, there's a location field in the AP. So I can say, hey, any AP that has this location information in it, if I learn it on this AP, then broadcast that traffic on this AP, right? So that MDNS advertisements would only go out on the locations or APs with similar locations. Excuse me. And then I have an AP name. So obviously it's only the AP I learned it on because APs would have unique names. It's going to get broadcast on that particular AP. Then the LSS is location specific services. It's the one that's used the most often. And I think probably by default, it is the right solution most often. What it does is it broadcasts if I have an advertisement that's brought in on an AP, it broadcasts it on that AP and the immediate RF neighbors. So just the APs that are considered the immediate neighbors RF-wise from this particular AP are also broadcasting that, right? So this kind of falls into kind of the RM domain, not a second hop or third hop or something like that, right? It's just those first hop neighbors that would broadcast that. Regular AP expressions. So now instead of using location or location or AP name, I can use a regular expression that's a partial of the name. So if the name is Dan Klamert floor one and Dan Klamert floor two, I could just put in Dan Klamert and I would get both floor one and floor two because that would match. I will say it's the regular expressions are very simple in the sense you're just basically putting in a partial. It's not what I typically think of with all the parentheses and all that kind of stuff. So it's a very simple way to do regular expressions. Site tags is another way to do it. So as you know, that's the way we break up our APs is by site tags. So you could say, hey, if I learn it on this site tag, broadcast on any AP on this site tag, and then I could do it on an SSID wide basis if I wanted to. Okay. Or I can say none. There's no location services. That is not sort of the recommended way to do this, right? So let's just take 30 seconds and talk about kind of best practice on this. Number one, if you're not using MDNS services, and why would I not use MDNS services, right? And we'll talk about that in just a little bit. But maybe I'm just using BLE, for example, and I don't need MDNS services. So if I don't need it, turn it off. There's a place I can set drop on the controller. Drop it on the switch if you can, right? Get it off the network as quickly as possible. If you are going to use it, then it's best to turn it on, turn on the gateway, put filtering in for anything you want, and then use location-specific services. If I just turn on the gateway and I don't use location-specific services and I don't filter, I'm going to use a lot of CPU on that from a controller standpoint. It's not something you want to do. Bridging is generally not best practice unless you're in some sort of small office or something like that, because now, just like we talked about before, you're just going to get overwhelmed with all of that mDNS traffic because you're not filtering any of that. So option one, turn it off completely. Option two, if you need it, turn on the gateway, turn on location services, turn on filtering. All right. So just from a best practice standpoint, as we look at this. Okay. So we talked about how local mode works with mDNS and the mDNS-AP and all that sort of stuff. How does Flexconnect work? Because in theory, the AP will continue to work even if it loses connection to the controller now, right? So how would this work? So what we do is we actually cache those mDNS messages in the APs themselves. So the APs are actually multicasting between each other, and they're talking to each other and providing that information about the services that they learn. Couple of caveats. Number one, if it's a wired, like S1 you see on the left-hand side is wired. S1 is only learned by the master AP. The master AP is the AP that does two things. One is it does a number of things, but two primary things. One is it snoops the wired traffic and pulls out the wired traffic and adds that to the database. Of course, it syncs that database with all the other APs, so all the APs have that gateway functionality synchronized in them. And by the way, you notice this is per flex group. So if I want to break this up, I just have different flex group. I'm assuming that in any flex group, I have all the same VLANs going to all the same APs anyway, right? So I'm only learning it on one, so I'm not duplicating that. I'm only learning on the master AP. And then the master AP's job is also to update information to the controller so that you can see things like, hey, what services are being advertised on my APs out there. So the controller is more in a management function here than a gateway function, but that information still gets reported up. All right. And so you can see I've got a little CLI display down below that shows an example, right? So I've got these different site tags, and it tells me per site tag, which is the master AP. And it's obviously in Flexconnect, the site tag is synonymous with a flex group here. Okay. All right, so that's the way it works in Flex. Very nice because even if you lost connection to the controller, the activity would still be there, right? That your gateway would still be there. All right, so let's talk about how we configure this, and then we're going to look at a configuration, and we're going to have to move quickly here. So services from an mDNS standpoint, we're going to go in. We're going to configure. First, we're going to do is configure multicast. Then we're going to configure mDNS. And then we're going to configure, if we want to configure the wired side, we're going to configure the VLAN or the SVI for the service policy. And then we're going to, on the WLAN profile, this is where we select bridge, gateway, or drop. So this is back to that best practice. If we don't need it, just drop it. If you're a little bitty office, you can bridge it. But if you're not, let's put it on a gateway and let's do this the right way. Okay. And then we're also going to, the service policy we built in the mDNS, so we're going to add to the service profile, and then we're going to put that on a policy tag, and then we're going to assign that to an AP. All right. So the one thing, if we're doing Flexconnect, we add is we do a flex profile, same place on the mDNS. And then on the flex profile itself, for the AP, we're going to add this, this flex profile that we created, this mDNS flex profile we created, we're going to add to the flex profile itself. That's going to get mapped to a site tag, and that site tag is going to get mapped to an AP. So yeah, it looks a little bit complicated. It's really not. And I like to use this as my cheat sheet to make sure I've kind of gone through the process. I'm going to skip ahead, and then we're going to come back at the end and go through the configuration example at the very end. But I just want to I want to introduce one other thing. So I won't have time to get into the custom wired services for Flexconnect, but basically we can filter at the interface with MAC addresses, VLANs, that kind of stuff for both controller and the Flexconnect AP. But this location-specific service for the mDNS-AP, I think, is important. So let's say that I have this network, and I have these various devices that are being advertised on the network. So I have these, let's say these are two different locations. Maybe they're floor 1, floor 2, or building 1, building 2, but they're actually in different physical locations. So they don't really see each other. And so in group 1, I have AP1 and AP2, and they're just regular old APs, and they're learning about Apple TV 1. And on the wired side, we're learning about printer 1 because you notice the VLAN, that red VLAN is extended to the controller at the top. Now, on the right-hand side, so that's the left-hand side. On the right-hand side, we have two APs, but one is considered an mDNS AP, right? So again, it's doing its regular AP functions, but we've added that mDNS functionality on top of it. You notice we don't have that red line anymore, or a dark blue line or anything like that going to the controller. Why is that? Because I'm learning that about those services, the wired services from the mDNS-AP. So Apple TV3 is learned by mDNS-AP3. Now, normally what would happen is AP1, AP2, AP3, and AP4 would all advertise Apple TV3 because the controller learned about it on the mDNS-AP. But I can turn on LSS for my mDNS-AP. And what that says is now only AP3 and AP4 are going to broadcast my Apple TV3 because it learned it on a wired AP that is in this particular location. So that lets me tie, and this is very unique. I don't think anybody else in the industry does this, right? So we can tie that location of the wired service to the wire where we advertise on the wireless services. Okay. All right.
Now, Al, real quick, there's a couple questions here, and I know we're running long, but these are some good questions. So for LSS, it can be as simple as turning that on, and then does that use RRM, or how does that work as far as location goes? I know we can be more prescriptive, like you showed a few slides ago, where you could put, like, if you wanted to do by floor, you could do location and things like that. But you know, I guess, how does LSS work in that regard?
All APs talk to each other. Something called the Neighbor Discovery Protocol, NDP messages, right? And so they go out at full power, and based on that, we can tell what signal level they're received at. If they're above, I believe it's minus 85, they're part of that immediate neighborship of that AP. So we can then define, and you can actually set some of those thresholds, but we can define what that neighborship level is for those immediate APs. So that is truly an RRM function, because we want to know what our neighbors are from an RRM standpoint. So it uses that exact RRM radio resource management function of determining who my neighbors are from an RF standpoint to determine what APs I should broadcast that mDNS functionality on.
Okay, thanks. And I know we did an episode previously on splash access. We got a question regarding splash access around, do I need LSS if I have splash access? I think those two are separate, complementary things, but that's the question.
Yeah, so if you're using splash access, then you can form these separate groups, right? And those groups are both layer 2 and mDNS, right? And multicast, right? So I can filter multicast based on those groups that we form. We call them UDN groups, right? Or WPN from a Meraki standpoint. I can filter those UDN groups out, which would be both layer 2 and mDNS. In this particular case, we're only filtering mDNS traffic with the gateway, right? But the thinking here is not everybody is, on a typical network, I'm not going to have a UDN group for every device that's out there, right? Normally, I would have no UDN group. So UDN kind of overlaps with this in the sense that it helps us manage. It's like a layer, so it's like forming little houses, right? And we talked about how mDNS works at home. So it's like building little homes out of our network, right?
Yeah.
What this does is it manages mDNS across the entire network.
Yeah. So the UDN is more like trying to create that home-like experience in the dorms, campus, wherever you are. Yeah. So, and then a few real quick, we had a couple. We've talked about Flexconnect a bit here, and there's a question still about. Is the Flexconnect limit of 100 APs in a Flex group is that still in play?
300. Yeah, 300 is the limit.
Yeah. Okay.
Yeah, we upped the limit to 300. So that is, I don't remember the software release. I'd have to go back and look at that.
That's fine.
But the group is up to 300 now.
Thank you very much. That's great.
Yeah.
Good news.
No, great. No, and so I think this is Flexconnect is a great way to go on some of this stuff, right? So, and I mean. Anyway, I won't go down.
Yeah,
about to go down a slippery slope here. I'm going to stay.
A whole nother episode.
Yeah, that's right. We do one on Flexconnect. Why Flexconnect? Why not Flexconnect? So, all right. So let's go through the configuration of this, right? So the very first thing that we're going to do is we're going to go in here to configuration, and then we're going to start with multicast in general, right? And so we're going to turn on multicast. You can see that's already enabled here. We're going to turn on the AP multicast mode. That's where we do the multicast, or multicast unicast, right? So we're selecting multicast. We give it an IP address, and generally what I do with the IP address, you want to give it something that is, not already assigned someplace. So I pick this address, and I usually use the last octet, that matches the last octet on my wires LAN controller. You want to make sure IGMP is snooping is enabled. And then you want to say what interfaces that's enabled on the far right over here. So we can pick like the client VLANs, the management VLAN if we want. We want to make sure that snooping is enabled on those particular VLANs. All right. So then we're going to go to mDNS. First thing when we get into mDNS is we can turn the gateway on or off, right? We can select, are we doing IPv4 or are we doing IPv6? That is an or. You can't do it on both. I don't have a lot of customers that really want to do mDNS and IPv6, but if you wanted to, we can, but it's either or. We set the active query timer. The query timer is how long, once that gateway learns the service, how long do I keep it in there if it's not refreshed, till it needs to be refreshed again, right? And then remember we talked about the mDNS-AP services or the mDNS-AP capability. This is where we define the policy for that mDNS-AP capability, right? All right. Now that service policy we're going to define it in the next step here, okay? All right, so the service policy, really, there is 4 different parts. We can define a service itself, and this is where we use those strings to define what a service looks like. So you can see that's what the configuration looks like. Here's a really bad example of one, right? And then the next is the service list itself. So now, remember we talked about in and out, and I said, hey, this is going to be important later. Notice up here, where underneath the list, we have right up here, if I get there, this in right here, we're defining the direction. So this is saying, what will the gateway learn about, right? Because this is taking it in. So I can say, what services do I want to learn about, right? And then I can also define, by the way, the top is available services, and then you have to open up that bottom where it says assign services right there to see I've assigned all, for example, in this particular case. Not a good example, let's just say that, but a simple one, right? Because you typically would want to filter just the ones that you specifically want to see. And so there's another list for out, right? So, and that defines what we're going to allow to be advertised out to the clients. And you can create multiple lists of in and out. And so it's not unique to this particular, you don't just have to have one, you can have multiple ones and then assign them as needed. All right, so then we have the service policy. So this is where we tie those service lists, the in and out, to a policy, and then tie that to a site tag. Let me start that to location rather. In this particular case, I've got the site tag assigned, but this is where we typically would assign like LSS, for example, or maybe a regular expression of AP names. So this gives us that ability to filter based on location. Okay. All right. All right. And then, of course, if we're doing wired filters, we can add wired filters here where we add the MAC addresses and the VLANs for those wired filters here. And this would then be put on our interfaces, could be put on the Flex interface or the controller interface. Here's a Flexconnect configuration. So this is where we're putting, remember I said we can put this on this is one of those new features we didn't get a chance to go into. I can put that wired service policy on the Flexconnect wired interface. And then I can define the statistics for that Flexconnect. Remember, with Flexconnect now, I'm going to have that gateway on the AP itself. Okay. All right. So I think we've seen all these different things. They're a part of that service policy. All right. So now let's see if we can. Let's go configure a Flexconnect profile. So now we have to assign that mDNS profile to a Flexconnect profile. So you see on the right-hand side right there, we have that mDNS Flex one that we just created that gets assigned. This is only for doing Flex APs. We wouldn't need those last 2 steps if we're not doing Flexconnect APs. But now every AP needs this policy configuration. So you can see we've got, I'm just going to pick one here. And if you go to the advanced tab, you can see over here, we have the ability to select that service policy. Remember, this has the in and out and the LSS or the location specific services assigned. I have another policy down here that I've done for Flexconnect, but it's the same thing, right? I'm going to assign that same policy to my Flexconnect APs. Then I'm going to go to the WLAN tab, and this is where we turn it on, turn it off, that sort of thing. And so I'm going to enable the gateway. So you see the mDNS mode for gateway there. And I'm going to, I could do drop or I could do bridging. Again, like we talked about from a best practice standpoint, in this particular case, I'm setting it up based on the gateway. And then this is kind of now back to sort of just how you configure a controller. So most everybody was probably aware of this, but we're going to assign those policy tags. We're going to assign those policies and WLAN policies to the policy tags. And then ultimately, we're going to assign those policies to the AP itself, right? So I'm just going to show you an example. This particular, this is a Flexconnect AP. I've assigned these Flexconnect profiles. The Flexconnect RF tag also is part of this, right? So I've assigned this to a particular AP. Okay. All right. So now you remember I said we would look at how to configure an mDNS-AP. All right. So this is the listener that was looking at saying, hey, how do I configure an mDNS-AP? This is how we configure an mDNS-AP. All right. So give it a second here to focus in. All right. So down at the very bottom, you see this command, AP name, and then this is the AP name for this particular AP. We're going to define it as an mDNS-AP and enable it on particular VLANs. Now, what's kind of cool is this is like doing a trunk interface, right? So be careful if you wanted to add a VLAN to this and you came in and said, hey, let's enable VLAN 2. You're only going to get VLAN 2, right? But there is, instead of enable, you can add, right? Or you can delete, or you can disable completely. You can instead of enable the mDNS-AP. All right. Again, this AP is just a normal AP. It's not anything particularly unique about this particular AP. I'd already configured this, so we got this error message. And then you can see, for example, show the mDNS-AP. It'll show you that they're configured, what VLANs are configured for. Again, this part is a wired only. Also, you can see that it uses the radio MAC for that. So if you go back and you look at the MAC address, we will go back and look at the MAC address that it defines for that is actually the radio MAC address. Okay. All right. So that's the configuration part of this. I'm going to stop. Is there, Dan, any additional questions or anything like that? I know we're kind of long on time here. There's a lot of stuff
we
to
are.
cover.
Well, someone liked the demo and they wanted to go back and were asking about the recording of it so they could go back and review it later. So I referred them to our link for the episode, which is going to be episode 42 on our YouTube channel, which is youtube.com/@getunplugged.
You bet. You bet. And what I can do also, I don't know what we normally do the slides. We can embed this in the slides too. So
sure.
But, yep.
All
and
right.
If you have any questions, I mean, everybody should have an assigned, I'll call them a TSA or SE,
Yes.
and if they're not sure how to do this, I'm happy to help with this, right? So let us know if there's anything we can do to help. I'm a firm believer that you should address MDNS. Turn it off or turn it on. And if you're going to turn it on, know what you're going to do with it when you turn it on. To me, it's sort of like doing the security on your on your wireless LAN. Know what you want, enable it.
Yeah.
If you don't want it, turn it off. Right. It's like whips.
In the business of running a network, you don't like surprises, and you're in for some surprises potentially if you don't address it one way or another.
Exactly. One thing that's important to note, and we kind of touched on this briefly, is there are services that only use BLE. For example, the Apple has some services,
the continuity mode, or some of these other things that
right, that are going to advertise on BLE. So your devices may still pick things up, even though you're doing things. Maybe you turn MDNS off, or maybe you're filtering. You may still get things directly, or maybe that's a solution so you can turn MD. I mean, if you got one display in the entire company, for example, right? And you only need it when you're sitting right next to it, and it has the ability to do something over BLE, just use BLE and disable it across the network. But again, be specific with your MDNS policies. That's my recommendation.
Agreed. All right. Well, I think this was a great episode. In the interest of time, I know we had some more content. We, wanted to talk about a wide area for what we do in wide area services, but be sure to subscribe to the channel, and we'll do another episode that we get to some of the more, that's the good stuff that we didn't get to here on this episode.
Yeah.
But
that one deserves a whole episode by itself because it's very unique in what its capability is.
Want to do it justice and not rush through everything. So thank you, Al. This has been great. I don't see any other questions. So I would just like to, again, thank everyone for tuning in here to Unplugged, episode 42. And please subscribe to our YouTube channel at Unplugged, or I'm sorry, youtube.com/@getunplugged. And you will be notified when we do go live with more great content out there. And you can also, like Al mentioned, if you do have questions, please don't hesitate to reach out. Reach out to your Cisco account team. They can get a hold of us quickly and easily. Otherwise, you can email us at getunplugged@cisco.com. That goes directly to us, and we're happy to answer any questions there. You can reach us on X, Twitter at Unplugged80211, or on Threads, Unplugged Connectivity. So until next time, stay connected and unplugged. Thanks.
Thanks, Dan.